show you the question. Let's discuss a past paper question. Can you see the question? Are you all able to see the question properly, Lamai? Please tell me whether all of you are able to see the question or not.
Can see, sir.
Right. Thank you, Buddha.
This question was given in 2008. This is the first essay question given in the paper. A diver of mass 50 kilogram is standing at the point C here, this point C. Of a 4-meter long horizontal diving board. What is the length of the board here? 4 meter, that is given. 4-meter long diving board. So that's given, right? So diving board means this. Of negligible mass, the board does not have mass, so you can neglect the mass of the board. Mounted on 2 vertical springs. This is the spring number 1, this is the spring number 2. The gap between the 2 springs given as 1 meter. At capital A and B as shown in the figure 1. Okay. Find the magnitude and direction of the forces acting on the board at capital A and B by the springs. Look at board here. Look at board. We can mark the forces acting on each people. That's the first thing we want to do, right? The force acting on the boy is, the first force is the gravitation attraction force. The gravitation attraction force acting vertically downward, right? Because of this force, the end C of the board is going to move down. Am I right here? NC, this is the point C, right? I have to keep the arrow like this, right? So NC is going to be rotated into this direction. Then what will happen here? If this end is trying to be moved, these are permanently fixed, right? Connected, fixed. There may be nuts and bolts to connect them. Then what will happen to the end area? If A and B permanently connected to these boards, when C is going to be moved downward, what will happen to the end area? Will it be going to move up or will it be going to move down there? Somebody unmute the mic and tell me.
Up, sir.
Sorry, dear, again.
Up.
Yes, that's the point. End A is going to be upward. It means length of the spring will be increased. Can you understand it? When C is going to be moved downward, and A tries to move up, Therefore, length of the spring will be increased. If the length of the spring is increased, what will be the direction of the force given by the spring? Lamai? Upward or downward? If the length is increased, the spring tries to decrease the length. Therefore, the force given by the spring will be acting downward. When C is going to be moved downward, due to the weight of the boy, spring B will be compressed. Point B will be compressed. So length of the second spring will be reduced. When the length of the second spring going to be reduced, what will be the direction of the force given by the spring B? I'll explain this in a different method, but I just want to give this explanation also, because there are some brighter students, they can understand even when I explain like this, but I'll use the normal whiteboard and give explanation, then everybody will be able to understand, right? Because of the weight of the boy, NC is going to be moved downward, then the spring B will be compressed and spring A will be stretched upward. When the spring when the length of the spring A is going to be increased, the spring give a downward force. B is compressed, therefore B will give a force of upward. So these are the direction of the three forces acting on this ABC diving board. Now I'll explain this using my normal whiteboard. Look at board. Right? Right. The story is like this. This is 2008 mechanics essay question. This is 2008 AL mechanics essay question. Mechanics essay question. 2008 AL mechanics essay question. Now look at board. Initially, the diving board was like this. Things were perfectly horizontal. If a boy stands on this one, the board will be like this. Earlier, it was like this. Now, due to the weight of the boy, the board has become like this. Then what will happen to this spring here? This end permanently connected, right? This end permanently connected. So what has happened here? Length of the first spring has been increased. What about the length of the second spring here? Earlier, everything was at this level. Now, this length of the second spring compressed. This is what you should identify. Length of the first spring increased because due to the weight, it has rotated like this. So length of the first spring has increased, length of the second spring has been decreased. This gap will be negligible small, right? Even I have gone a huge angle, you will not get such a huge angle in this standing fall down. Right? So this angle will be negligible small. Even the spring is compressed, actually you can consider that it is already to be at rest horizontally. But even a very small amount of the length of the spring A will be increased, even a very small amount of the spring will be, second spring will be compressed. When a spring is compressed, it will give a force upward. F2 Newton. When a spring is stretched, it will give a force downward F1 Newton. This is what will happen. And weight of the buoy acting downward as mg Newton. So this angle theta is a very small angle. Therefore, you can consider that the board already to be in horizontal. But even the theta is small, there is a small amount of increase in length. There's a small amount of decrease in length. Due to the increasing and decrease in length, the two springs will give two forces like this. When the length of a spring is going to be increased, the spring tries to decrease the length, giving an oppositely directed force downward. When the length of a spring is stretched, reduced, it tries to keep the original length by giving an upward force. That's it. The force given by spring can be found by the equation F equals Vx. Draw the two figures here. So the first figure shows without buoy, the second figure shows with the buoy. That's it. Draw both figures quick. Come on. Write the heading as 2008 AL mechanics essay question and draw the figures. The first figure without buoy, the second figure with the buoy. Draw them please. Right, I think time is enough for you to draw the figures, right? Is the time enough for you, all of you, to draw the figures?
I think time is more than enough for you to draw the figures, right? So when the string is this, when the due to the weight of the boy, it will be rotated slightly like this, an angle of theta, right? So second string compressed, first string is stretched, therefore forces are formed like this, right? I'm going to give you a small description. In the examination, no need to draw such figures there because examiners know physics. Therefore, no need to draw figures and teach them physics. Do not try to teach physics to the examiners. Therefore, no need to draw such figures and such descriptions. I'm going to give a description. Do not write that description in the exam paper. No need. Right. Please write. Due to the weight of the boy, due to the weight of the boy, the board is slightly rotated an angle of theta due to the weight of the boy. Please write. Due to the weight of the boy, the board is slightly rotated an angle of theta and comes to rest. Due to the weight of the boy, the board is rotated an angle, rotated slightly and rotated slightly. Due to the weight of the boy, the board is rotated slightly an angle of theta and comes to rest. And comes to rest. Full stop. Then, please write, then the first spring is stretched. The first string is stretched, S-T-R-E-C-H-E-D, stretched. Within brackets, its length is increased. Its length is increased. The first string is stretched. Within brackets, its length is increased. Close the bracket. Then it gives a vertically downward force to the board. Then it gives a vertically downward force to the board. It gives a vertically downward force to the board. Full stop. Full stop. Next line, next point. At the same time, the second spring is compressed. At the same time, the second spring is compressed. 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 Within brackets, its length is slightly reduced. Within brackets, its length is slightly reduced. Compressed, its length is slightly reduced. Full stop. Therefore, the second spring gives a force vertically upward. Therefore, the second spring gives a force vertically upward. Therefore, the second spring gives a force vertically upward. Star point and write. Star point and write. The above angle theta is very small. The above angle theta is very small. Therefore, it can be assumed that the above angle theta is very small. Therefore, it can be assumed that the board is to be in horizontal direction, to be horizontal. Therefore, it can be assumed that the board to be horizontal. The board to be horizontal. Or board is horizontal. Right. Somebody please unmute the mic and read the complete description. Somebody please quickly unmute the mic and read the description.
Due to the weight of the board is slightly rotated to an angle of theta and comes to rest. When the first spring is stretched, in brackets, its length is increased. Then it gives a vertically downward force to the board. At the same time, the second spring is compressed. Within brackets, its length is slightly reduced. Therefore, the second spring gives a force vertically upwards. Start point, the above angle theta is very small. Therefore, it can be assumed that the board to be horizontal.
Thank you, Riel. Thank you very much. Right now, in the exam, you should start with the answer with this figure. In the exam, you should start the answer with this figure. The first spring gives a force of F1 Newton, downward. F1 Newton, downward. The second spring gives a force of F2 Newton upward. The man gives a force of mg Newton vertically downward. Let me mark the points A, B, C, right? The distance, this distance is 1 meter. This distance should be 3 meter because the total length is given as 4 meter. Draw the figure here. So this is how you want to, with this point you want to start the answer. Draw the figure. What's the question numbers? We have they given as Roman numbers O, A, B, C. Roman number 1. Roman number 1. Saying Roman number 1, draw this figure. In the exam, no need these figures and the previous descriptions. Right. And you should remember that mechanics equations are always combinations of linear motion, circular motion, and fluids. Everything will be combined together and give a single equation, right? Not only linear motion, not only circular motion, not only fluid. It will be a combination. Draw the figure and please tell me, then I'll go for the calculations. Once you draw the figure, send a message Zoom chat saying done. Then I'll go for the calculations. Right, I'll erase the previous figures. Right. Look at board B. We have learned something so-called moment of a force. Right, let me recall your memory. Moment of a force was defined as moment of a force. Moment of a force is defined as the force into perpendicular distance. Perpendicular distance from the axis of rotation or point of rotation, but that's not important factor, right? So this mg force try to rotate the rod into this direction. This direction is said to be the clockwise direction. If you consider point B, this mg force try to rotate the rod into the clockwise direction. Clockwise direction. Rotate the rod to clockwise direction. The amount of effort given by this mg force to rotate the rod into the clockwise direction is said to be the moment of the force, right? The amount of the effort given by this mg force to rotate the rod into the clockwise direction is said to be the moment of the force. Similarly, if you consider point B, this F1 force try to rotate the rod into the anti-clockwise direction because it's downward, acting downward. So it tries to rotate the rod into the downward direction. So that is anti-clockwise. Clockwise direction, anti-clockwise direction. F1 force is trying to rotate the rod into the clockwise direction above the point B. The amount of effort given by this F1 force to rotate the rod into the anti-clockwise direction is again said to be the moment of that force. If the rotating effort into the clockwise direction is equal to the rotating effort into the anti-clockwise direction, the rotating efforts are cancelled out, the rod will be at rest. The rod will be at rest horizontally, which is said to be equilibrium. So we can write an equation something like this. Look at board here. For the equilibrium of the rod. For the equilibrium of the rod, what's the condition? About the point B, please wait, I'll explain again. Let me write, I will explain. For the equilibrium of the rod, about the point B, this condition must be satisfied. What's the condition? The moment into the clockwise direction. The moment into the clockwise direction, right? The rotating effort into the clockwise direction, that's the simplest meaning, should be equal to the moment, into the anti-clockwise direction. Please don't write, I'll give you the time. Let me explain. For the rod to be at rest, it means for the rod to be in equilibrium. About the point B, rotating effort into this direction must be equal rotating effort into the other direction, which are said to be the moments. A moment of a force can be found by this equation, force into perpendicular distance. So moment about the point B by the mg force is mg, perpendicular distance from the point B to mg is 3 meters. Force into the anti-clockwise direction is rotating effort into the anti-clockwise direction is given by the force F1. The perpendicular distance from the point B to F1 is 1 meter. M is given as, let me write the rest here. M is given as 50, G is 10 into 3 equals F1 into 1 is F1. So 5 times 3, 50, 00, 1500. So F1 is 3 times 550, yes, 1500. So this is how we find it. Write them all. If you want, you can write this as a note. This equation can be written as a note if you want. Right. Let me do the same thing to the other point also. Look at board here. If you consider point A, let's say if you consider point A, mg force is still trying to rotate the rod into the clockwise direction. If you consider point A, let's say you have keep your finger here, then mg force is trying to rotate the rod into the clockwise direction. What about F2 force? If you consider point A, what will do F2 force? Is it trying to rotate the rod into clockwise direction or anti-clockwise direction? Somebody unmute the mic and tell me. About the point A, mg force is trying to rotate the rod into the clockwise direction. I'm asking about the point A, what is the direction F2 force trying to rotate the object? Clockwise direction or anti-clockwise direction? You are silent, mean time will be wasted. Yes, dear, someone?
Anti-clockwise direction.
Anti-clockwise direction. What about others? What is the direction that the F2 force is trying to rotate the object here? Clockwise or anti-clockwise? At least two more students give me the answer.
Anti-clockwise direction, sir.
Anti-clockwise direction. Very good. You save the time. So F2 force is trying to rotate the rod into the anti-clockwise direction, while F1 is trying to rotate the rod into the clockwise direction. So let me erase this, right? Let me erase this. For the equilibrium, about the point A. Now I'm taking moments above the point A. The moment into the clockwise direction, rotating effort into this direction should be equal to the moment into the anti-clockwise direction. Moment into the anti-clockwise direction, rotating effort into this direction. Once the rotating efforts are cancelled out, the road will be at rest. Let me erase them because we have already obtained this. Right. Moment into the clockwise direction is force into perpendicular distance. The force is mg, perpendicular distance from the point A. Now we are taking moments about the point A. Perpendicular distance to the force from the point A is 4 meter equals force is F2, perpendicular distance. Perpendicular distance is 1 meter, only 1 meter, right? So M is 50, G is 10, this is 4 equals F2 into 1 is F2. So you will get the answer as F2 equals 4 times 5, 20, and with the 2 zeros it will be 2000 Newton. 2000 Newton. That's it. So we have found F1 and F2 forces. Can somebody tell me to check whether the answers are correct or wrong? Is there a method to find whether F1 and F2 answers are correct? Can somebody tell me? We have found F1 and F2. F1 has 1500 Newton, F2 has 2000 Newton. Is there a method to check whether the answers are correct or wrong? Anybody? A math student?
F2 equals sum of F1 and mg.
Very good, very good, excellent. The summation of upward forces must be equal to summation of downward forces. So therefore F2 should be equal to F1 plus mg. We can check it. That's what we want to do. Why not? That's what's said to be the equilibrium of parallel forces. That is what's said to be the equilibrium of parallel forces. But my advice is find F1 and F2 by taking moments about points A and B and use the parallel force equilibrium concept to check whether your answers are correct or wrong. So that's for the security, right? Parallel force equilibrium means vertically upward forces should be equal to vertically downward forces. Right? How do we check the answers? Let me write the check. To check the answers, upward forces, if F2 is the only upward force, F1 and mg acting downward. So summation of the downward forces, F1 and mg should be equal to the upward force F2. So let me take F1 to this side. If like this, downward force is F1 plus F2 equals F2. Upward, downward forces, F1 and mg acting downward, F2 acting upward. Summation of the downward forces equal to the upward force. Then let me take F1 to the other side. So mg equals F2 plus F1 from this side as minus F1. F2 is 2000, F1 is 1500. So 2000 minus 1500 means 500 Newton, correct? Right, M is 50, G is 10, 500. So our answer is correct. So this is how we check whether the answers are correct. By this method, you can check whether your answers are correct or wrong. Right. M is 50, G is 10. So 50 times 10 should be 500. We got 500 by considering our values of F1 and F2. That's what we did. So it means our answers are correct. So we should be very happy.
2, let me read the question for you. Listen to me carefully. The diver, it means the boy, performs a dive. Consider the motion of the center of gravity of the diver. Its path is indicated by a dotted line as shown in figure 2. This is the figure 2. So this dotted line indicates the path followed by the center of gravity of the boy. Center of gravity is the point through which the gravitation attraction force acting. On any object, the earth applies a force which is acting vertically downward. That force is said to be the gravitation attraction force. The gravitation attraction force is always acting through a certain point. That point is said to be the center of gravity. So this dotted line shows the path followed by the center of gravity of the boy. Right? Now let's read. Its path is indicated by a dotted line as shown in figure 2. The point capital G is G, which is 4 meters above the water surface at the beginning of the dive. Dive means the jump. Enters the water surface at Y after completing the path in 2 seconds. XY equal 2 meters. So what's the total time taken for the boy to travel from point capital from this platform to the Y? What's the total time taken for this motion, Lamai?
2 seconds.
2 seconds. Very good. Please talk to me, dear. When once you answer my questions, it's easy to teach. Then only I can understand whether you have understood, whether you have listened to me, or whether the video is clear or not. Those things. Find the horizontal and vertical components of the initial velocity of capital G. G is the center of gravity of the boy, which is said to be the diver. Right? So please write the heading. I think you have already written the heading as 2008 A-level fast paper, first essay question. So today we are going to answer Roman number 2. We have already answered Roman number 1. For Roman number 2, you should draw this figure. I want to mark some points. They have used X and Y. Let me mark the starting point of the motion as W. And let me use a red color for it. So what is W, dear? W is the starting point of the motion. Look at board. Actually, this section is not circular motion. This is just projectile motion, right? Listen. I can mark initial horizontal velocity component of the boy. Actually, it has a certain velocity into this direction. You can divide that velocity along 2 perpendicular directions such as ux and uy. So it means the original velocity, the velocity of the boy when he leaves the platform is, it's not a horizontal velocity, u meter per second. U meter per second is the initial velocity of the boy when he leaves the platform. Right? That velocity can be divided into 2 sections as ux and uy. So horizontal velocity component is ux. Vertical velocity component is uy. Vertical velocity component is uy. I am not going to write the units. Right? So what is the velocity of the boy when he leaves the platform? U. And we have divided that velocity in 2 sections. I think you should remember resolving a vector into 2 components. For example, if you mark this angle as theta, right, or alpha, right, ux is u cos alpha. If you mark this angle as alpha, uy is component away from the angle is u sin alpha. Ux, uy equal u sin alpha, ux equal u cos alpha. Those things are well known things. Resolving a vector into 2 components. We have already completed that theory part. Then let us consider the position of the boy, actually its center of gravity, when he reaches to the maximum height. Right? So let me keep the heading away. We keep the heading somewhere here. Right? So when the boy reaches to the maximum height, you should remember this theory. Right? When a particle is moving up, the vertical velocity component becomes 0 at a certain height. But in a projectile motion, horizontal velocity component remains unchanged. If you have not learned projectile motion, you have to join to the other class to complete those sections. Right? You should send me a message to my WhatsApp and you have the chance to complete it. So at the maximum height, let me mark horizontal and vertical velocity components like that. So the point here is in projectile motion at the maximum height, vertical velocity component, if I mark it as Vy, that is 0. Vy is 0, right? So similarly, but the point in a projectile motion, horizontal velocity component never be changed. It remains unchanged as ux. If the initial horizontal velocity component is ux, anywhere in the motion, horizontal velocity component remains unchanged as ux. Even when the object, actually object means the boy, here we are considering his center of gravity. Even when the boy hits the water surface, he's not jumping to a concrete surface, it's water surface, right? So even the boy hits the water surface, his horizontal velocity component remains unchanged as ux. That's the magic. Right, now please draw this figure here for Roman number 2. Just draw this figure. Start. Draw it. Draw and mark all the given data. Right, you want to mark one more thing. Listen dear, we should mark this height. It means this is the starting horizontal level. If I mark like this height is, you see, it's given as 4 meters. They have given this height as 4 meters. Again, we should mark another height from this level, the maximum height reached by the particle, like this. Here, from this level. Right. This is given as simple h. Initial height, simple h is given as 4 meter. And this is the next height, which is h max. Right. So h max is the maximum height reached by the particle. In projectile motion, you should remember that horizontal velocity component never be changed. So if you have not learned projectile motion, you must send me a message to my WhatsApp so I can help you. I can help you to cover those sections. If you have not learned projectile motion, you may send a message to my WhatsApp after the class, but not now, because while I'm teaching, I will not check WhatsApp. Therefore, send a message after the class. So this is h max. H max is the maximum height reached by the particle. Right. Now everything is perfect, right? So particle first the particle starts motion at W, it ends the motion at Y. So here also I want to use another letter. I have to use another letter for that point. Let me take that point as W dash. So W dash is the maximum height reached by the particle. So particle travels from W to W dash. Okay. The particle travels from W to W dash. Then W dash to Y. W to W dash. I think you can say you are able to see it. W to W dash. And W dash to Y. That's how the particle travels. The time taken for the entire motion, they have given it as 2 seconds. Find the horizontal and vertical velocity components of the initial velocity of capital G. The easiest method is I can apply W to Y. Listen to me carefully. W to Y. Along the horizontal direction, I can apply the equation is equal ut plus, listen to me carefully, do not write, just listen to me, is equal ut plus half at square. So here, I'm answering the question, Roman number 2, right? Here I apply this equation along the horizontal direction. Therefore, let me indicate the direction. I apply this equation along the horizontal direction. So in all the projectile motion questions, you must indicate the direction. Listen to me carefully, dear. So initial, let's say this is ut plus, somebody unmute the mic and tell me what is the acceleration component of a projectile motion along the horizontal direction? Somebody, what is the acceleration?
0, sir.
0. Very good. So everybody should remember that acceleration component of a projectile motion along the horizontal direction is 0. 0 into anything? 0. Therefore, half into 0 into t square is 0. Therefore, you will get ut plus 0 into anything is 0. So it means along the horizontal direction, the is equal ut plus half at square equation just become ut. Therefore, in your school teacher will directly write is equal ut without writing these steps. Okay, dear? He will not write these steps. He will directly write is equal ut. Got it? So horizontal displacement, when the particle travels along the dotted line path, what is the horizontal displacement here? Horizontally, it has traveled only a 2 meter distance, right? What is the horizontal displacement of the particle? Just 2 meter. Along the horizontal direction, it has traveled only 2 meter, right? Therefore, if you apply this equation, if you apply this S equal ut plus half a square. Equation on the horizontal direction, the horizontal displacement is 2. Horizontal velocity component, I have marked it as ux. Time taken for the motion is given as 2 seconds. Right? So if you take this 2, if you take this 2 to the other side, this is the horizontal velocity component ux. So if you take this multiplication to the other side, it will be division 2 divided by 2 equals ux. So it means 2 and 2 cancelled out. You get horizontal velocity component is 2 divided by 2 is 1. Unit is meter per second. Do not forget to write the units. Complete dear. Please complete this. Right, we have found the horizontal velocity component. This is division, right? 2 divided by 2 is 1. The unit is meter per second. So we have found the horizontal velocity component. Right. Then how do you find the vertical velocity component here? How do we find the vertical velocity component? We should apply the same equation, but this time now W to y, I'm going to apply the same equation. Same equation means S equals u. Please look at board. Do not write anything. S equal ut plus half at square. I apply the same equation, but this time I apply the equation vertically downward. This time I apply the equation vertically downward. That's the point. Now look at board. Please listen to me carefully. If you listen, you can understand only if you listen to me carefully. Otherwise, you will not understand this. Therefore, give your maximum concentration. Listen to me carefully. Right. So if you consider the entire motion, it travels from W to Y. Once the entire motion is considered, right, horizontal displacement is 2 meters. It is given. Vertical displacement is 4 meters. So it means displacement should be measured along 2 directions, whatever the path followed by the object. In a projectile motion, whatever the path followed by the object, the displacements are measured only along 2 directions. That's why sometimes it is called 2-dimensional motion. Right? In some textbooks, you may have seen that projectile motion is said to be 2-dimensional motion. 2-dimensional motion means we measure displacement only along 2 directions, horizontal and vertical. So for the entire motion, horizontal displacement 2 meters, vertically downward displacement is 4 meters. Therefore, if you apply the equation S equal ut plus half a square downward, the downward displacement is 4 meters. So if you have not learned these things, you must inform me. Send a message to my WhatsApp. then I can help you to cover them. Vertical velocity component, I am applying the equation downward, but vertical velocity component at the point W, Uy acting upward. I am applying the equation downward, but the initial velocity component Uy is acting upward. So velocity is a vector. When the directions are opposite, we should use a minus sign. I'm applying the equation downward. The initial vertical velocity component Uy is upward. So as the directions are opposite, I must use a minus sign into time taken. For the time taken for the total motion is 2 seconds, right? 2 seconds plus half into downward acceleration. Lamai, when an object is moving freely under the gravity, what should be its downward acceleration? Somebody unmute the mic and tell me, dear. Yes, that is simple g plus simple g plus simple g. Time taken is 2. We should get time taken is 2. We should get square of 2, because 2 square and t square means 2 square, right? So this is it. I think everybody will be able to find the value of Uy by using this equation. Find Uy and send your answer to my Zoom chat. Okay. So Roman number 1 was related to moments. Roman number 2 related to projectile motion. Find Uy and send your answers to my Zoom chat. And the other thing is, if you select the vertical direction, you should consider only the things along the vertical direction. So as I'm using the equation S equal to T plus half AT square equation vertically, I should consider only the vertical velocity component Uy. I should not consider the horizontal velocity component Ux. We consider only the horizontal things. Vertical things, we consider only the vertical things, because the direction is vertical. Whether it is downward or upward, the direction is vertical. Find Uy and send your answer to my Zoom chat. Start. Right, so let's try to solve this. 4 equals minus 2 into Uy is 2Uy plus this is half into simple g is 10 into 2 square is 4. Square of 2 is 4. Then we will get 4 equals minus 2uy plus, you see this 10, sorry, this 4 or 10 divided by 10 into half. 10 into half means 10 divided by 2. So that is 5. That is 5. So we have 5 times 4. 5 times 4 is 20. So I'll do something like this. Let me take minus 2y to this side. Right? What will I do? I'll take minus 2y to the other side. So it will be plus 2uy equals 4 times 5 is 20 plus 4 come to this side as minus 4. I think you can understand that maths. 5 times 4 is 20 minus 2uy come to this side positive 2uy plus 4 goes to the other side as minus 4. So then you get 2uy equals 20 minus 4 is 16. So if you take 2 to the other side, you will get uy equals 16 divided by 2. So if you divide 16 by 2, you get the answer as 8. So vertical velocity component is 8 meter per second. Who got this answer? Lamai, please raise your hand up if you got this answer. Please raise your hand up in the Zoom chat if you got this answer. Okay. Very good. I'm so happy. Please write them all. After that, let's move to the next question. Right. So what are the things that we have found? We have found the horizontal velocity component as 1 meter per second. In both times, we have applied the same equation. We have applied the same equation in both cases. And finally, we have found vertical velocity component, initial vertical velocity component as 8. So those are the things that we have found so far. Right. So I'll keep them like this separately. Right. I think horizontal part you have completed. So let me erase them. I think these black color things you have written. So let me erase them. Right. So horizontal velocity component is 1 meter per second. Vertical velocity component, let me write them together. Vertical velocity component, we have found it as 8 meter per second. I have written them together because I can erase the board now. Right. Let's go for Roman number 2, simple B. Calculates simple Roman number 2, simple A. We have found these answers. Simple A, Roman number 2, simple B. Calculate the maximum height reached by capital G from the water surface. Where is water surface here? So actually water surface means this. This is the water surface, right? The boy hits on the water surface, right? The boy hits, this is the water surface, right? Boy hits on the water surface. So let me mark it as water surface. Right. Now we want to find H max. But they ask the maximum height reached by the buoy from the water surface. It means we should find this height starting from here. We should find this height starting from this point like this. So the total height is asked. So we know the half, we know this part. This is 4 meter, this is H max. So if we are able to find H max plus 4 meter is the total height reached by the buoy from the water surface. So very simple. Look at board there. W to W dash, right? Vertically upward. Let me use the equation. V square equals U square. V square equals U square plus 2AS, right? So at the maximum height, I'm applying this equation vertically. At the maximum height, vertical velocity component is 0. Therefore, V is 0. At the maximum height, it is 0. Square equals initial vertical velocity component is Uy, but we have to get the square of it. We have to get the square of it, power 2. Plus 2, somebody unmute the mic and tell me what is the upward acceleration. When an object is moving freely under the gravity, right? I'm applying the equation upward. Therefore, what is the upward acceleration component of a projectile motion? Lamai?
Minus G.
Very good. That is minus G. The value of G is 10. So I put minus G. So the distance from point W to W dash, the vertical displacement, I am applying the equation vertically upward. Therefore, W to W dash vertical displacement is H max. So this is H max. This is H max, right? Can you do the rest and find H max? Try to do the rest of the calculations. Find the value of H max and send to my Zoom chat. Please remember that we are applying the equation vertically upward. Do not forget the direction. Find H max and send to my Zoom chat. Start. H max is the horizontal displacement from W to W dash. That is vertical displacement. Vertical displacement, and we are applying the equation vertically. At the same time, it has some horizontal displacement. That horizontal displacement is not asked in the question. We are answering simple B part of the same question. Roman number 2, simple B. Complete this, dear. So square of 0 is 0. It's nothing. Uy, we have found it as 8. So we should get square of 8. Here we have minus g plus 2. Minus into plus minus. 2 into g is 10 into h max. Right? So 0 is 0. Square of 8 is 64. Minus 2 into 10 is 20 h max. Minus 20 h max. This is h max. Minus 20 h max goes to the other side as plus 20 h max equals 64. If you take 24 to the others, 20 h max equals 64. If you take 20 to the other side, you can find h max. So h max equals 64. Here, this is multiplication 20. Multiplication 20 goes to the other side as division 20. That's how it goes to the other side of the equation mark. So 64 divided by 20. That's much easier, right? 64 divided by 20. 64 divided by 2 is 32. Divided by 10. It can be done like that, right? So if I divide both numbers by 2, you get the 64 divided by 2 will be 32. If you divide 20 by 2, it will be 10. So I have divided both numbers by 2. Now 32 divided by 2 means 3.2 meter. 3.2 meter. 3.2 meter. Who got this answer? Lamoy? Please raise your hand up if you have obtained this answer. Anybody? Very good. Please write everything. 32 divided by 10. So the thing that I have done here, I have divided 64 and 20 by 2. Then 64 becomes 32, 20 becomes 10. 32 divided by 10 is 3.2. That's how I got this answer. So, but this is not the final answer. So 3.2 meter is the displacement from the initial level. But the question asks the maximum height from the water surface. So maximum height from the water surface means the summation of this 4 meter and h max. Right. So I think you have written this part. So I'll erase. I'm going to erase this part and I'm going to write the final answer for Roman number 2, simple B. So I'll erase it. Right. The question asks the maximum height. This is what they ask. Maximum height from the water surface. That's what they have asked. So you should find the maximum height from the water surface. Okay. So maximum height from the water surface means summation of this 4 meter, simple h and h max. So that is simple h and simple h max both. Right. So I have to manage the space. So let me write at once, that is 4 meter plus 3.2. 4 plus 3.2 means 7.2. 7.2 meters. So this is the maximum height reached by the boy from the water Right, so we have found the maximum height from the water surface. Unfortunately, we were disconnected. Now I think things are okay, back to normal. Right, listen to me carefully. We have answered both simple A and simple B. Now we should try for simple C. Calculate the following at the highest point of the path of the diver. The highest point we have marked it as W dash. The translational kinetic energy means the linear kinetic energy, half m square, and the gravitation potential energy relative to the water surface. So what are things we want to calculate? Potential energy relative to the water surface and the kinetic energy of the buoy when the buoy is at his maximum height. Right. Let me share you the diagram. After that, let's do the calculations. Right, I think you are able to see the diagram. This is the diagram that we were using, right? So at the moment we were disconnected, that's why video is somewhat not clear, right? So the question asks us to find the kinetic energy when the object reaches to this W dash point and the potential energy. So first of all, let me find kinetic energy, right? So we are answering Roman number 2. Simple C question. The first thing they say translational kinetic energy means linear kinetic energy. That's what they have asked. So at once I can write, you should write kinetic energy complete term, but I write just Ke equals, actually there is only one velocity component because Vy is 0. So particle has, this person has kinetic energy only due to the Vy velocity. So half m into x square. So you should clearly identify that this person has kinetic energy only due to the Vx velocity component because Vy is already 0. Vertical velocity component at the maximum height is 0. Therefore, no need to worry about the Vy velocity component when you calculate in the kinetic energy. So please write this and find the kinetic energy of this person at its maximum height position and send your answers to my Zoom chat. The mass of the person is 50 kilograms. You may have forgotten it. Mass of this person is 50 kilogram and Vx already we have found. So this is half into mass of the buoy is 50. Somebody please tell me what the Vx is. Vx is equal to Ux. That's the point. Vx is equal to Ux. That's the magic of the projectile motion, right? So in all the projectile motions, horizontal velocity component remains unchanged. So we have half into mass is 50 into Ux is, somebody please tell me, initial horizontal velocity component. Lamai? Yeah, even you can see it here. Here you have it. Ux equal 1. So it is 1. So square of 1 is 1. 50 into half means 50 divided by 2. 50 divided by 2 is 25 into 1 means 25 joules. So kinetic energy of the buoy at its maximum height position is 25 joules. Completed there?